Have you ever looked at an app like Instagram or Spotify and just wondered, how? How can a few simple lines of Python code power something so complex? Well, today we're going to pull back that curtain and see exactly how Python turns simple code blocks into massive architectural blueprints.
So that's the real question we're tackling, right? How does Python actually scale up? How do you get from writing a few basic commands to building robust, powerful software? We're going to trace that exact path, step by step.
And to do that, we've got a four-part journey. First up, we'll look at the individual bricks, the absolute core components of the code. Then we'll see how to create blueprints for our code using objects. After that, we're grabbing some specialized toolkits with modules, and finally, we'll learn how to make our whole structure strong and smart by controlling the program's flow. All right, let's dive right into part one, the core components. You know, every great structure has to start with the most basic materials. And in the world of code, that means understanding the fundamental building blocks. The first, and maybe the most essential building block, is the function. The best way to think of it is like a named, reusable recipe. You write the code once, you give it a name, and then you can call on it to do that one specific thing whenever you need it. This is really the first big step to keeping your code clean and super efficient. And Python is really flexible here. Most of the time, you're going to use these standard named functions with def. But sometimes, you just need a tiny throwaway function for a quick one-off task. And that's where a lambda comes in. Think of it as a little one-line anonymous function, perfect for simple calculations on the fly. Okay, so functions are great, but what do they actually work on? Well, they work on data. And the most common way to group data together in Python is with a list. It's just like a shopping list, right? It's an ordered collection of items that you can change anytime you want, all just wrapped up in those square brackets. Now here's where it gets really powerful. Lists come with their own built-in tools, or methods. Need to add a new car to your list? You just use .append. Want to remove the last one? That's .pop. You can even sort or reverse the entire list with a single command. Python just gives you all these essential tools right out of the box. So we have our basic building blocks down. Now it's time for a really major leap. In this next section, we're jumping into the world of objects. This is how we go from just writing lines of code to actually designing reusable, intelligent blueprints. And that brings us to this massive idea in programming called object-oriented programming, or OOP for short. Imagine this. Instead of having a car's properties, like its color and speed, in one place, and its actions, like start engine and accelerate, somewhere totally different, you group them all together into one single car concept. That's really the whole idea behind OOP. Now, the most crucial thing to get here is the difference between a class and an object. The best analogy, and you'll hear this a lot, is that a class is the blueprint for a house. It defines all the properties a house should have. The object, on the other hand, is the actual house you build from that blueprint. You can build tons of houses, tons of objects, all from that one single blueprint. So how do we actually use this blueprint? Well, it's basically a three-step process. First, you define the blueprint itself using the class keyword. Second, inside that class, you create a special __init method. You can think of this as the instruction manual for what to do the second a new object is created. And finally, you actually build it. You create an object or an instance from that class.
The real power of these blueprints shines with something called inheritance. So imagine you have a blueprint for a basic vehicle. Then you can create a car blueprint that inherits everything from vehicle, but then adds something new, like a number of doors. It lets you build on work you've already done. And that super function, that's the key that lets the car use all the original vehicle features before adding its own stuff.
Okay, we've got our blueprints, but guess what? We don't have to build everything from scratch. In this section, we're going to learn how to grab pre-built toolboxes with modules and how our applications can talk to other applications using a common language. So what is a module? Honestly, just think of it as a pre-packaged toolbox. It's just a file full of functions and code that someone else already wrote and perfected. By using a simple import statement, you can bring that entire toolbox into your project and start using all its tools right away. It's a huge time saver. Now, when your app needs to get data from a server, let's say you're getting the latest weather from an API, they need to speak the same language. And these days, that language is almost always JSON. It's just a simple text-based way to format data that's super easy for both humans and computers to read. And lucky for us, Python has a built-in JSON module to handle it all. Let's see how simple this is. Say you have a Python dictionary, which is just a bunch of key value pairs. You can turn it into a JSON string with one single command, json.dumps. That's it. And boom, here's the result. Our Python dictionary is now just a plain text string in the JSON format. The key thing to notice is how universal this is. Any application written in any programming language can now perfectly understand this data. It's a universal translator. And the translation between Python and JSON is so intuitive. As you can see, Python's data types like dictionaries and lists map directly over to JSON's objects and arrays. It's pretty much a perfect one-to-one conversion, which makes working with data from the web in Python just incredibly smooth. All right, for our final section, let's talk about making our code really robust and intelligent. We're going to cover how to control the program's flow by gracefully handling errors and by performing really powerful text searches. You know, in the real world, things go wrong. A file might be missing, a network connection could drop, and instead of letting our whole program crash, we can use a try-except block. It's basically a safety net. You try a piece of code. If it works, great. If it fails, the except block catches the error and deals with it gracefully. And that finally block, it runs no matter what, which is perfect for any cleanup tasks. So, what if you need to find a very specific pattern inside a giant block of text? For that, you need regular expressions, or regex. Think of it like a find and replace, but on steroids. It's a tiny, powerful language for defining super complex search patterns. And Python's remodule is your go-to toolkit for this. For example, you could use findAll to pull every single email address out of a huge document. Or you could use sub, which is short for substitute, to find every time a name is misspelled and correct it instantly. It's an unbelievably powerful tool. So let's just take a quick look back at our journey. We started with the absolute simplest bricks, individual functions. Then we learned how to draw up architectural plans using classes. We brought in specialized toolkits by importing modules, and we learned how to build resilient structures that can handle problems with try and except. So we've gone from the most fundamental bricks all the way to the architectural plans. Those building blocks are now blueprints, and they're in your hands. So really, the only question left is, what are you going to build first?